Human curiosity about life beyond Earth stretches back thousands of years, evolving from myths and religious beliefs into the beginnings of scientific inquiry in the Renaissance and beyond. The shift from supernatural explanations to empirical research marked a significant transformation in our understanding of the universe. Early foundations of scientific thought. The ancient civilizations of Mesopotamia, Greece, and Egypt all had their own myths and interpretations of the stars and the heavens, often involving gods and divine beings from distant worlds. However, it wasn't until the advent of modern astronomy in the 16th and 17th centuries that humanity began to view the cosmos through a scientific lens. Figures like Nicholas Copernicus, Johannes Kepler, and Galileo Galilei transformed our understanding of the universe, shifting from a geocentric view, Earth as the center of the universe, to a heliocentric one, where Earth and other planets revolved around the Sun. This was a foundational shift that laid the groundwork for later speculation about extraterrestrial life. In the 19th century, the Industrial Revolution and advancements in scientific observation, combined with an increasing fascination with the potential for life elsewhere, set the stage for the more modern scientific inquiry into the possibility of extraterrestrial civilizations. Scientists like Sir William Herschel, the astronomer who discovered the planet Uranus, speculated on the existence of life on other planets, particularly Mars, given its apparent similarities to Earth. The birth of astrobiology. The 20th century brought about a significant leap in the scientific search for extraterrestrial life, culminating in the establishment of astrobiology, the study of life in the universe. With the advent of the space age, this interdisciplinary field would combine aspects of astronomy, biology, chemistry, and physics to examine whether conditions for life might exist on other planets and moons within our solar system and beyond. The concept of habitability, where certain conditions are necessary for life to thrive, became central to astrobiology. Research increasingly focused on finding environments that might support life, from extremophiles on Earth, organisms that thrive in extreme conditions such as deep-sea vents, acidic environments, and frozen landscapes, to the search for exoplanets in the habitable zone of distant stars, where liquid water could exist. The origins of SETI. In the 1960s, a groundbreaking initiative emerged, one that would come to symbolize the scientific pursuit of alien life in a way never seen before. The Search for Extraterrestrial Intelligence, SETI. The SETI program sought to detect signals from intelligent alien civilizations using radio telescopes, following the hypothesis that advanced civilizations might communicate across vast cosmic distances using electromagnetic waves, much like we do with radio waves on Earth. The first significant effort in SETI came in 1960 when astronomer Frank Drake, working at the National Radio Astronomy Observatory in Green Bank, West Virginia, began conducting what became known as the Project Ozma experiment. Using a radio telescope, Drake targeted two nearby stars, Tau Ceti and Epsilon Eridani, and attempted to listen for artificial signals. Though no signals were detected, the experiment marked the first scientific attempt to listen for alien communication, planting the seeds for the SETI field. The search for signals, challenges, and discoveries. For decades after Drake's initial experiment, SETI efforts primarily focused on the detection of narrow-bandwidth radio signals, hypothesizing that such signals, when detected, would be artificial in origin, as natural cosmic phenomena typically emit broader, more diffuse signals. The WOW signal, detected in 1977 by astronomer Jerry Emin, remains one of the most famous and unexplained SETI events. A strong, brief radio signal was detected from the direction of the constellation Sagittarius, but despite further attempts to detect similar signals, none have been found. This mysterious event continues to fuel speculation about extraterrestrial origins. While no definitive signals from extraterrestrial intelligence have been detected to date, SETI remains an active field of research. In the 1990s, a breakthrough came in the form of the discovery of the first exoplanet, a planet orbiting a star other than the Sun. This opened new possibilities for SETI, expanding the search for habitable planets beyond our solar system and encouraging new methods of detection, such as monitoring for unusual light patterns or periodic dips in starlight caused by an alien megastructure, a concept popularized by the Dyson sphere hypothesis, which posits that advanced civilizations could construct vast structures to capture energy from their stars. The technosignature search. In recent years, the concept of technosignatures has gained traction within the SETI community. Technosignatures are signs of alien technological activity, such as artificial light, unusual energy emissions, or even signals from an alien satellite. One prominent example is the study of unusual star behavior, such as that observed in the star KIC 8,462,852, Tabby star, which exhibits irregular dimming patterns that some have speculated could be the result of a large, artificial structure orbiting it. While technosignatures remain speculative, their pursuit has become a broader part of SETI's ongoing efforts. The search has moved beyond radio signals to include other potential indicators of alien life, thus making the study of extraterrestrial intelligence more diverse and technologically advanced. The role of telescopes and new observation methods. As technology progresses, so too does our ability to detect signs of extraterrestrial life. Telescopes have become increasingly powerful, offering new insights into distant stars, planets, and galaxies. In 1992, astronomers discovered the first exoplanet orbiting a sun-like star, leading to an explosion of interest in the search for habitable worlds. In the 2010s, the Kepler Space Telescope revolutionized the study of exoplanets, revealing thousands of new planets, many of which exist in the habitable zone where life could potentially thrive. The James Webb Space Telescope, launched in 2021, is poised to take this research even further. Webb's advanced infrared capabilities will allow scientists to study the atmospheres of exoplanets in unprecedented detail, searching for chemical signatures of life such as oxygen, methane, and carbon dioxide that could indicate the presence of biological activity. Space missions and extraterrestrial environments. Simultaneously, space missions targeting the moons of our own solar system are uncovering evidence of potential habitats for life. The moons Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, both show signs of subsurface oceans beneath their icy crusts, environments where microbial life could potentially exist. NASA's Perseverance rover, which landed on Mars in 2021, continues the search for signs of past life on the red planet. Scientists have long speculated that Mars may have harbored microbial life in its distant past when conditions were more Earth-like. Perseverance is tasked with drilling into the Martian surface to collect soil samples that will later be returned to Earth for analysis, potentially answering questions about ancient life on Mars. As the technology of space exploration advances, humanity's ability to detect subtle signatures of life, whether microbial or intelligent, will only increase. The ability to send spacecraft to distant worlds, analyze their atmospheres and surface conditions, and even look for signs of life within their icy moons marks an important step forward in our understanding of extraterrestrial life. The search for extraterrestrial life beyond the solar system. Looking further into the future, the possibility of direct contact with extraterrestrial life may not be as far-fetched as it once seemed. With advancements in space travel, like the proposed development of faster spacecraft, humanity may eventually have the technology to visit distant exoplanets and study them up close. Efforts to create generational ships capable of supporting human life for centuries could enable deep space exploration on a scale previously unimaginable. There are also ongoing discussions about using laser technology to send targeted messages to potentially habitable exoplanets. These messages could be the next step in the SETI initiative, proactively seeking to establish communication with distant civilizations rather than merely listening for signals. The future of extraterrestrial life research lies at the intersection of scientific curiosity, technological innovation, and philosophical reflection. As space exploration advances, the possibility of discovering microbial life in the subsurface oceans of Europa or Enceladus, or even on a distant exoplanet, becomes more realistic. The quest for signals from extraterrestrial intelligence, while yet unfulfilled, continues to push the boundaries of radio astronomy and data analysis. Future technologies, including artificial intelligence, AI, may help in processing vast amounts of data from SETI and other space missions, enabling faster identification of potential technosignatures and biological markers. The rise of private space companies, such as SpaceX, could also lead to more frequent missions to distant planets, bringing us closer to the reality of interstellar exploration. In the coming decades, humanity may find itself not only contemplating the existence of alien life, but also engaging with it, whether through microbial discoveries or the first contact with intelligent civilizations. The pursuit of knowledge, of understanding our place in the cosmos, will continue to drive exploration, with each breakthrough taking us one step closer to answering one of the most profound questions humanity has ever asked: are we alone in the universe? Chapter 5: A New Frontier: The Integration of AI and Data. As humanity's capabilities to explore and understand the cosmos expand, so too does our reliance on cutting-edge technology. The integration of artificial intelligence, AI, into scientific research has become a pivotal development, especially in fields such as astronomy, astrophysics, and SETI. AI and big data in SETI research. For decades, SETI efforts have been limited by the sheer volume of data generated by telescopes scanning the universe for potential signals. Traditionally, astronomers would sift through massive datasets, looking for anomalies that could indicate intelligent life. However, the complexity and scale of this task have made it an arduous and time-consuming process. Enter artificial intelligence. In recent years, AI has become an indispensable tool in SETI research. Machine learning algorithms are now being used to sift through petabytes of data far more efficiently than human researchers ever could. These algorithms can be trained to recognize specific patterns in data that may indicate an artificial signal, whether it be a narrowband radio wave, a modulated light pattern, or an unexpected anomaly in a distant star's behavior. By learning from vast datasets, AI systems can identify potential signals that would otherwise go unnoticed. One notable breakthrough occurred in 2023 when an AI system trained to analyze radio frequencies discovered an unusual pattern of signals from Proxima Centauri, our closest stellar neighbor. The signals were initially dismissed as cosmic noise, but after further analysis, the AI system flagged the pattern as potentially unique. Although the signals turned out to be of natural origin, the AI-driven investigation sparked a renewed interest in the possibilities of intelligent life beyond our solar system. This success led to more ambitious projects in which AI plays a crucial role in both searching for technosignatures and analyzing complex data from telescopes, space probes, and satellites. The use of AI has opened up new avenues in the search for extraterrestrial intelligence, not only allowing for faster processing of data, but also enabling a deeper understanding of the patterns that may indicate alien life. Advancements in space exploration technologies. Alongside AI, new advancements in propulsion systems, spacecraft design, and space robotics have dramatically transformed the landscape of space exploration. One of the most exciting developments is the continued research into faster-than-light (FTL) travel, or the theoretical concept of warp drives. While still within the realm of theoretical physics, studies in this area have suggested that it may be possible to bend spacetime itself, creating a warp bubble around a spacecraft, allowing it to travel faster than the speed of light. Although no physical warp drive has been created yet, the theoretical work in this field keeps hope alive that interstellar travel could one day become a reality. Even if warp drives remain speculative, other advancements have already proven useful. The development of ion propulsion, which provides higher efficiency than traditional rocket engines, is already enabling spacecraft to travel to distant planets and moons in our solar system. Space missions like NASA's Dragonfly, a rotorcraft designed to fly through Titan's atmosphere, and the European Space Agency's JUICE mission to explore Jupiter's moons, are poised to increase our understanding of potential habitats for alien life. These missions, along with future ventures to Venus, Mars, and beyond, are laying the groundwork for humanity's quest to explore not just our solar system, but the wider universe. The search for extraterrestrial life and intelligence is not just a scientific endeavor, it is a cultural, philosophical, and societal one. The discovery of life beyond Earth, whether microbial or intelligent, would have profound implications on the way we view ourselves and our place in the universe. Societal reactions to extraterrestrial life. While the scientific community prepares for the eventual discovery of alien life, society as a whole remains divided on how it would respond to such a revelation. Would humanity embrace this discovery with excitement and curiosity, or would fear and skepticism prevail? The discovery of microbial life on Mars or one of Jupiter's moons might elicit widespread enthusiasm and affirmation that life is more common in the universe than previously thought. But the discovery of intelligent life, be it through the detection of technosignatures or even direct contact, could lead to a more complicated and potentially fraught response. Historically, humanity has had a tendency to fear the other, and this reaction might be amplified if the life forms encountered are radically different from us in terms of biology, technology, or culture. The potential for peaceful contact is just as much a subject of debate as the possibility of conflict. The fear of hostile alien civilizations, ingrained in science fiction narratives from War of the Worlds to Independence Day, has been a powerful motivator for many. It leads to the question, if intelligent life exists, how do we prepare for contact? Should humanity develop protocols for peaceful interaction, or should we be more cautious, adopting a more defensive stance? The global conversation surrounding extraterrestrial life would also challenge our religious and philosophical views. For many, the discovery of life beyond Earth would force a reevaluation of humanity's position as the crown of creation and potentially upend traditional theological narratives. Could extraterrestrial life be viewed as evidence of a greater divine plan, or would it challenge religious doctrines about human exceptionalism? Ultimately, how society reacts will depend on the context of the discovery. If the encounter is peaceful and offers mutual benefits, the world may unite in celebration and collaboration. However, the discovery of alien intelligence may also bring about new political and ethical challenges, especially if different nations or private interests vie for control over alien technologies or knowledge. The search for meaning, the philosophical impact. Beyond the practical and societal implications, the search for extraterrestrial life poses deep philosophical questions that challenge our assumptions about the nature of life, intelligence, and consciousness itself. As scientists continue to explore the possibilities of life in extreme environments, a question emerges: what defines life? Is it simply the ability to reproduce, consume energy, and evolve? Or does intelligence and consciousness play a critical role in what it means to be alive? If we were to encounter alien life, it is conceivable that their form of existence may challenge our own definitions of life. They could be non-biological entities, living as sentient machines, or they may exist in forms that we cannot even comprehend, such as energy-based life or life within the fabric of spacetime itself. The discovery of intelligent life would force humanity to confront the nature of intelligence and consciousness. If an alien species is technologically advanced, would we consider them more intelligent than ourselves? Or would we recognize that intelligence is multifaceted, shaped by evolutionary and environmental factors that are unique to each species? Philosophically, the search for extraterrestrial life also raises existential questions about the meaning of life itself. If we are not alone in the universe, how does this change our understanding of existence? Are we simply one of many sentient species in a vast cosmic community, or are we unique, the only instance of conscious life in a vast, silent universe? As humanity enters a new era of space exploration, the possibilities seem endless. The prospect of discovering life, whether microbial or intelligent, has the potential to revolutionize our understanding of the universe and our place within it. Yet, there are still many unknowns, and the future of space exploration holds both excitement and uncertainty. The next steps in space exploration. The next decade promises to be an exciting time for space exploration. Mars will remain a focal point of research, with both robotic and human missions continuing to search for signs of life or past habitability. But the focus is also shifting to the outer reaches of the solar system, where moons like Europa and Enceladus offer tantalizing possibilities for the discovery of life beneath their frozen surfaces. The James Webb Space Telescope will continue to study distant exoplanets, while future missions may even probe the atmospheres of these planets to detect biosignatures. The ultimate goal, however, may lie beyond our solar system. With the development of faster propulsion technologies and the theoretical possibility of interstellar travel, humanity may one day embark on missions to stars beyond our own. Proposals for sending probes to Alpha Centauri, our closest neighboring star system, are already in the works, though they remain decades or even centuries away from reality. Nonetheless, the search for life elsewhere in the universe will continue to drive exploration, with each new discovery bringing us closer to the answers we've been seeking for centuries. A unified vision for humanity. In the end, the search for extraterrestrial life is not just about finding alien life, it's about finding a shared purpose for humanity. As our understanding of the universe deepens, and as our exploration of space progresses, the dream of exploring the cosmos together will unite us across borders, cultures, and ideologies. The possibility of encountering other civilizations, or learning that we are alone in the universe, will force humanity to confront its deepest questions, its hopes, and its fears. Whether we find life that challenges our understanding or life that affirms our place in the cosmos, the journey ahead will define the future of humankind. It will be a future driven by curiosity, exploration, and the relentless pursuit of knowledge. And as we continue our quest to reach the stars, we will redefine what it means to be human, connected to the universe, to each other, and to the infinite possibilities of life itself. Chapter 8: The Dawn of Interstellar Exploration. The next frontier: interstellar probes and faster propulsion. As the 22nd century begins, the pace of technological advancement and space exploration accelerates. What was once considered science fiction is now on the brink of becoming reality. Humanity has made significant strides towards sending probes and eventually spacecraft to other star systems. The challenges that once seemed insurmountable, such as interstellar distances and timescales, are now being addressed with innovative new technologies. One of the most exciting developments is the concept of light sail propulsion, a method of travel that utilizes radiation pressure from lasers or the sun to push ultra-thin sails to high speeds. These sails, when propelled by high-powered lasers, have the potential to reach speeds up to 20% of the speed of light, allowing humanity to send unmanned probes to neighboring star systems in a matter of decades rather than centuries. The Breakthrough Starshot Initiative, an ambitious project funded by private and public organizations, marks the first significant step toward this goal. By 2055, the first interstellar probe Starshot 1 was launched toward Alpha Centauri. This tiny probe, no larger than a postage stamp, carried sensors and cameras capable of detecting planets, stars, and other celestial phenomena, as well as looking for possible signs of alien life. The successful launch of Starshot 1 is a triumph of engineering, and the mission is expected to reach Alpha Centauri in just over 20 years. Despite the immense distance, the breakthrough moment comes when the probe sends back its first data from the Alpha Centauri system in the year 2080. The images from the probe reveal a previously unknown exoplanet orbiting a red dwarf star, its atmosphere exhibiting the telltale signs of water vapor and a potential biosignature. This marks the first direct evidence of a planet with the necessary conditions to support life, an exciting breakthrough for astrobiologists and SETI researchers alike. The first signs of extraterrestrial life. By 2085, after decades of searching, the first direct evidence of extraterrestrial life is uncovered, not in the form of intelligent civilizations, but in the discovery of microbial life on Europa, one of Jupiter's moons. A robotic mission led by a coalition of Earth nations, Europa Lander 3, lands on the icy surface of Europa and begins drilling into the moon's subsurface ocean. In 2086, after weeks of searching, the mission discovers microbial fossils embedded in the icy crust, evidence that life once thrived beneath the frozen surface. The announcement reverberates throughout Earth, shaking the foundation of human understanding. The discovery is monumental, but also raises as many questions as it answers. If life existed on Europa, what does that mean for the likelihood of life elsewhere in the universe? The implications are staggering. It suggests that life could emerge anywhere the right conditions exist, from the icy moons of distant gas giants to the depths of interstellar space. The discovery does not come without controversy. Some critics argue that the finding is simply a sign of Earth's evolutionary inevitability that life is bound to form under the right conditions. Others see the discovery as proof of a larger cosmic ecosystem, a vast, interconnected web of life spread across the stars. The debate continues, but the scientific consensus is clear: life, in some form, is not unique to Earth. A message from beyond the stars. While humanity celebrates the discovery of microbial life, something even more astonishing occurs, an event that will forever alter the course of human history. In 2092, a team of astronomers at the SETI Institute detect an unambiguous signal coming from the direction of the star system Tau Ceti. The signal is unlike any known natural phenomena, and after extensive analysis, it is concluded that the signal is artificial in origin. The signal itself is a repeating pattern of pulses, a mathematical sequence that seems to be an invitation of sorts, possibly a greeting or a signal for communication. Over the next several years, experts around the world work tirelessly to decode the message. The signal is encoded in a series of binary numbers, and once decoded, it reveals a complex system of information, including star charts, mathematical theorems, and even a rudimentary form of language. Humanity now faces the ultimate question: what to do next? The signal is clearly intelligent, but who or what is sending it? And how do we respond? A new era of communication. The breakthrough leads to the establishment of a global collaboration, spearheaded by international space agencies and the world's leading scientific minds. The communication is not one way. After months of careful analysis and preparation, Earth sends its first reply to the alien signal in 2094, using the same mathematical principles and binary code. The reply includes Earth's star map, a summary of human history, and a demonstration of our scientific achievements. In the following decades, communication continues, but it is slow and methodical. The alien civilization, later dubbed the Telcorians, are located in the Tau Ceti system, approximately 12 light-years from Earth. The exchange of knowledge is limited due to the time lag, but already, humanity has begun to benefit from the alien technology transmitted through the signals. The Telcorians share advanced techniques in energy production, sustainable agriculture, and even basic biotechnology. While the nature of their society remains a mystery, their desire for peaceful interaction is clear. Over time, Earth builds its first interstellar communication network, utilizing a combination of quantum entanglement and laser communication to bridge the vast distance between stars. The diplomatic process begins, albeit cautiously. Nations, in response to these interactions, form a unified governing body to deal with the Telcorians, the Interstellar Council, to establish frameworks for trade, cultural exchange, and potential collaboration on scientific ventures. The first contact, a momentous event. In 2112, after decades of slow and careful communication, the Telcorians reveal their plans to send a delegation to Earth, a ship designed to traverse the vast distances between their star system and ours. The idea of physical contact becomes a reality, and preparations on Earth take on a new urgency. How do we welcome visitors from another world? What safeguards must be in place? How do we ensure that this first meeting is not a disastrous one? The moment of first physical contact takes place on Mars. The Telcorian ship, which is designed to resemble a sleek, elongated structure, lands in the vast plains of the Martian equator. The diplomatic delegation includes scientists, engineers, and diplomats from Earth, and the arrival of the Telcorians is broadcast across the world. The aliens themselves are humanoid in form but vastly different in appearance. Their skin is translucent, their eyes large and multifaceted, and their features are bioluminescent. The first handshake between an Earthling and a Telcorian is captured in history books, a symbol of the beginning of interstellar cooperation. The language barrier is overcome through the advanced technologies sent via the signal, and humanity begins to learn about the Telcorians' ancient civilization that travels across the stars, and their decades-long search for life elsewhere in the universe. A unified galactic civilization? The following century brings forth an age of unprecedented progress. Humanity, no longer confined to the boundaries of Earth, establishes colonies on Mars, Europa, and beyond. With the help of the Telkorians, humanity develops faster than light propulsion systems, enabling interstellar travel to neighboring star systems. The cooperation between Earth and the Telkorians leads to a renaissance of scientific discovery. Medicine, energy production, and technology leap forward at an exponential rate. The shared knowledge from two civilizations once isolated by the vastness of space leads to a period of unprecedented peace and prosperity. But the encounter with the Telkorians raises new philosophical questions. As humanity expands outward into the cosmos, it must confront the responsibilities of interacting with other life forms. The Interstellar Council evolves into a galactic governing body, coordinating efforts not only between Earth and the Telkorians, but also with other alien species discovered during humanity's expansion. The discovery of alien life, once a distant dream or source of existential dread, is now a cornerstone of humanity's identity. The story of how humanity came to understand that we are not alone in the universe is retold through generations as a tale of unity, curiosity, and exploration. The quest to understand extraterrestrial life has now become part of humanity's journey into the stars. The future is uncertain, but one thing is clear: the search for knowledge, the drive to explore the unknown, and the possibility of connecting with alien civilizations will continue to shape the human spirit for centuries to come. As humans step forward, side by side with the Telkorians and other extraterrestrial species, into the depths of space, they realize that they are part of something much larger, a vast, interconnected cosmos where the potential for discovery is limitless, and the bonds of life, intelligence, and cooperation are woven across the stars. And with every new discovery, every new encounter, humanity continues to ask itself the same question that has driven its journey for millennia: what lies beyond the horizon?